In this video, I will show you how to solve trigonometric equations by factoring. Throughout this video, I'm going to assume that you have memorized this chart of trig values. For example, you should know that the cosine of pi over 6 is radical 3 over 2 right off the top of your head. If you have not memorized these values yet, please pause the video and memorize them right now. For a couple of the problems, we're going to need to use some of these Pythagorean identity variations. So you should also either have this chart memorized or get yourself to the point where you could generate this chart in a minute or two. We will be restricting our solutions to the interval from 0 to 2 pi. In other words, one turn around the unit circle. Looking at problem number 7, as soon as I see that we have a squared term and a non-squared term, I'm thinking this will probably factor as a binomial times a binomial. All right, a two-piece times a two-piece. I always start with the first term, so sine squared x. That can be only factored as sine x times sine x. Skip the middle term for now. Look at the third term. How can this be factored? In other words, what times what makes 2? Well, this can only be 2 times 1. So that makes this pretty easy. You can hear me say the following phrase. Inner plus outer equals middle. Inner, we have these two terms, 2 and sine x. If you multiply those, you get 2 sine x. Outer, I'm talking about the sine x and the 1. If you multiply those, that will just be 1 sine x. So we have inner and outer. Inner plus outer must equal the middle. The middle is the negative 3 sine x. I can control whether or not these are positive or negative. What do they need to be to add up to negative 3? Well, I would need a negative 2 and a negative 1. That translates into negative 2 here and a negative 1 here. Before we declare victory, check one last thing. You have to make sure that you really get positive 2 for the constant at the end. Negative 2 times negative 1 is a positive 2, so we did it. This worked out great. So now that we have factored, we will use the zero product property. When you have something times something equals 0, either the first factor equals 0 or the second factor equals 0. You're going to get a solution either way. So we can get solutions by setting sine x minus 2 equal to 0, and we can get more solutions by setting sine x minus 1 equal to 0. We just need to solve both of these separately. Adding 2 to both sides, we get sine x equals 2. Adding 1 to both sides, we will get sine x equals 1. So we need to solve both of these, and looking at sine x equals 2, normally I would be asking myself, what's the reference angle? The sine of what angle is equal to 2? But there's a problem here. Not only is that not on the chart that we've memorized, all right, the sine of nothing is going to give us 2. But there's a bigger problem. Sine is the y value on the unit circle, and the y value will have a maximum value of 1 and a minimum value of negative 1 at the top and bottom of the unit circle. You cannot have a y value that's greater than 1. So there's no sine value. There's no angle that will have a sine of 2. So we will get no solutions from this part. So we really can just cross that out. There will be no solutions here. You know what? I'm not even going to write no solution because we are trying to solve this equation overall. And as long as we get solutions from the other side, then there is a solution. So what I don't want to see, I never want to see you do this. No solution. Then put a nice little box around that, and then solve this one and get a solution. Okay, maybe this turns out to be pi over 2, say. All right, this is not two separate problems. You can't have no solution and a solution. So do not write no solution unless the other equation also has no solution. Well, I kind of gave away the game here. Sine of what angle is equal to 1? Looking at our unit circle, we just mentioned that sine is the y value, and the y value will be 1 up here at the very top. This is the only place. So this is pi over 2. So that is the only solution for problem number 7. So we're going to solve this by factoring. I'm noticing that we have a quadratic term, meaning it is squared, and then we have a linear term, which is not squared. So that is a clue to me that this is probably going to factor as a binomial times a binomial, a 2-piece times a 2-piece. So I'm going to start with the first term, 2 sine squared x. There's really only one way to factor this term. I'm going to have 2 sine x times sine x. That would give me 2 sine squared x. For the moment, I'm going to ignore the middle term, and I'm jumping over to the third term. What times what will give me 1? I'm ignoring the negative sign for now. Well, that can only be 1 times 1. So that's going to make this a relatively easy problem. To figure out if this is going to work, I need to look at the inner terms and the outer terms. The inner terms, 1 times sine x, that will give us sine x. The outer terms, the 2 sine x times 1, that will give us 2 sine x. In other words, we have 1 sine x and 2 sine x. The inner terms plus the outer terms have to equal the middle. Inner plus outer equals middle. So the middle is negative 1 sine x. I can control whether or not these are positive or negative. If I pick the signs correctly, I can get negative 1. How do I need to pick the signs to give me negative 1 sine x? Well, I would need this to be positive, and I would need this to be negative. Together, that will make negative 1 sine x. That translates into this being positive 1 and this being negative 1. This makes sense because the positive 1 sine x comes from positive 1 times sine x. And the negative 2 sine x came from the outer terms, negative 1 times 2 sine x. Anyway, there's one more thing we have to check. Always make sure that when you multiply the last terms, you get the final term. So in other words, positive 1 times negative 1 does equal negative 1. So everything is working out great. I'm going to go ahead and erase this because it's kind of in my way. So we factored it. To continue and find the solution to the equation, I'm going to use something called the zero product property. When you have something times something equals 0, well, either the first thing equals 0 or the second thing equals 0. So we can get one solution by setting 2 sine x plus 1 equal to 0. And we can get another solution by setting sine x minus 1 equal to 0. So now we have two little equations to solve. For the first equation, let's subtract 1 from both sides, and that will give us 2 sine x is equal to negative 1. Dividing both sides by 2, we have sine x is equal to negative 1/2. So let's go ahead and follow through on this. What is the reference angle? The reference angle is going to be pi over 6. Ask yourself, the sine of what angle is equal to 1/2? And the answer is pi over 6. And we're getting that from the chart, which you should have memorized. The sine of pi over 6 is 1/2. So there are 4 angles that have a reference angle of pi over 6, 1 in each quadrant. In honor of the reference angle, I can call pi 6 pi over 6, and 2 pi can be thought of as 12 pi over 6. So one position before 6 pi over 6 would be 5 pi over 6. Similarly, this is 7 pi over 6. And this is 11 pi over 6. And of course, in the first quadrant, you just have the reference angle itself. So the sine of any of these angles will be 1/2. It's just that in the first quadrant and the second quadrant, we get positive 1/2. All right, sine is a y value. It's positive in these quadrants. And in the third quadrant and the fourth quadrant, we will get negative 1/2. In this case, we want sine of x to equal negative 1/2. So that's why the solutions will be x equals 7 pi over 6 and 11 pi over 6. Okay, so those are the solutions that we get from the left side, the 2 sine x plus 1. So I'm just going to erase this. And now we're going to work the right-hand side. So let's add 1 to both sides. We will get sine x is equal to 1. I started to ask what the reference angle is going to be, but I'm realizing that this is going to be a quadrantal angle situation. So there will be no reference angles. Keep in mind that at the quadrants, the coordinates are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. The sine of what angle is equal to 1? Well, remembering that sine is a y value, we're looking for a y value of 1. And we see that right here. So that's why the only solution is pi over 2. So in addition to the 2 solutions that we already have, we will also have pi over 2. All right, and we can just sort of tack that on to our previous list. So we have 3 solutions to problem number 8. Number 9 looks weird. We have secant and we have tangent in the same problem. We really need to fix that in some way. Perhaps we can use our Pythagorean identities. So I see that secant squared right here is equal to 1 plus tangent squared. So let's make that substitution. So I will replace secant squared with 1 plus tangent squared. And then I'm just going to bring down the rest of this. So plus tangent x minus 1 is equal to 0. I'm now noticing that we have a plus 1 and a minus 1 over here. So those are going to cancel each other out. And now I'm going to have tangent squared x plus tangent x is equal to 0. I no longer have a trinomial, so I'm going to get out of the mindset of thinking binomial times binomial. If I only have two terms, I'm going to look and see if there is a common factor, a GCF. And right away, I see that both of these have a tangent. So let's factor tangent out. So let's pull tangent x outside of the parentheses. That will leave me with tangent x plus 1 inside the parentheses. Again, we are going to use the zero product property. When you have something times something equals 0, either the first thing equals 0 or the second factor will equal 0. Either way, you're going to get some solutions. So what about this first one? Where is tangent equal to 0? Picture the unit circle for a moment. I need to know where tangent is equal to 0. Okay, let me scoot this over just a little bit. The coordinates here are 1, 0, and this is 0, 1. And here is -1, 0, and this is 0, -1. So think about the tangent of each one of these positions. Tangent is sine over cosine. Well, maybe I'll just go straight to this. Tangent is y over x. All right, keep that in the back of your mind. All right, tangent. All right, I'm going to put tangent theta so it's not confusing. Tangent is y over x. So, y over x, so that would be 0 over 1. So that's going to give us 0. Okay, y over 0, 1 over 0, that is undefined. 0 over -1. That is going to give us 0. -1 over 0, that is undefined. So if the question is, where is tangent 0? Tangent of what angle is 0? Well, that's happening in two positions, here and here. That is 0 and pi. So we have two solutions so far. We have x is equal to 0 radians and pi radians. So let's continue on and solve the second mini equation. For this, we need to subtract 1 from both sides. So that's going to give us tangent x is equal to -1. So here again, we need to picture the unit circle. Ask yourself, what is the reference angle? Tangent of what angle is equal to 1? I'm ignoring the negative sign for a minute. Hopefully, you were just thinking to yourself that the reference angle is pi over 4. Think about the facts that we have memorized. The tangent of pi over 4 is equal to 1. So that's why the reference angle is pi over 4. There are 4 angles that have a reference angle of pi over 4. There's 1 in each quadrant. With a reference angle of pi over 4, I'm going to think of pi as 4 pi over 4. And I will think of 2 pi as 8 pi over 4. So that makes this 3 pi over 4, and this is 5 pi over 4. And this is 7 pi over 4. And this, of course, is the reference angle itself of pi over 4. The tangent of any of these four angles will be some kind of a 1. It's just that we will get positive 1 in the first quadrant and in the third quadrant, and we will get negative 1 in the fourth quadrant and in the third quadrant. Well, in this case, we want tangent to equal negative 1. So that's why the solutions will be 3 pi over 4 and 7 pi over 4. Okay, so I'm really going to just bring this down a tiny bit so I can just sort of tack these on. So the solutions will be 0 and pi from the first factor. And now I'm going to get these two additional solutions of 3 pi over 4 and 7 pi over 4. So we get 4 solutions for problem number 9. For problem number 10, I'm noticing that we have a common factor in both terms, sine x. So when you have a common factor, you really want to pull that factor outside of parentheses. That's going to leave 1 where the sine x was, and minus 2. All right, this sine x is out front now, but I still have my cosine x. So this is what would be left inside the parentheses. Let's use the zero product property. If something times something is equal to 0, we can get solutions by setting each factor equal to 0. So sine x equals 0, and 1 minus 2 cosine x is equal to 0. Now we will solve each of these separately. So this is going to be the easy one. Sine of what is equal to 0? I'm thinking this is going to be a quadrantal situation. So just picture this with me. Okay, over here on the right, this is 1 comma 0. This is 0 comma 1. This is negative 1 comma 0. And this is 0 comma negative 1. Sine is the y value. So we're looking at the 0, the 1, the 0, and the negative 1. We want sine to equal 0. So we want the y values to equal 0. That's going to happen here and here. So we have two solutions, 0 and pi. So we have x equals 0 radians and pi radians. So that's what we get from the first little mini equation. Now let's solve the second equation. Let's go ahead and I guess I'll subtract 1 from both sides. So I will have negative 2 cosine x is equal to negative 1. Now I'm going to divide both sides by negative 2. So that will leave me with cosine x is equal to positive 1/2. Negative divided by a negative is a positive. So what is the reference angle here? So I was giving you time to think. Hopefully you were thinking, hey, the reference angle is pi over 3. You're asking yourself the cosine of what angle is 1/2. And if you have this chart memorized, you see that the cosine of pi over 3 is 1/2. So the reference angle is pi over 3, but that's not the final answer, because there are 4 angles that have a reference angle of pi over 3. There's 1 in every quadrant. Since the reference angle is pi over 3, I'm going to think of pi as 3 pi over 3, and I'm going to think of 2 pi as 6 pi over 3. That makes this angle right here 2 pi over 3, and this angle is 4 pi over 3. and this angle is 5 pi over 3. And the reference angle itself, of course, is the first quadrant, pi over 3. The cosine of any of these angles will be some kind of 1/2. It's just that cosine is positive in the first quadrant and in the fourth quadrant, over here on the right-hand side. So I will get a positive 1/2 from these two angles. Cosine is negative on the left, so these two would give me a negative 1/2. Since I want a positive 1/2, that's going to be pi over 3 and 5 pi over 3. So in addition to the two answers I already have, I'm going to tack on pi over 3 and 5 pi over 3. So problem number 10 has 4 solutions. Last problem. I'm noticing that both terms have a common factor of cosine. So when you see a GCF like that, go ahead and pull that outside of parentheses. If I take away this cosine, I'm going to be left with 2 cosine minus radical 3. All right, I took one of the cosines away from here, and I took this cosine and I put it back here. Now I can use my zero product property. When something times something equals 0, you set each factor equal to 0, and you will get solutions from each mini equation. So set each of these equal to 0. Let's solve this first one. Cosine of what angle is equal to 0? That sounds like a quadrantal angle situation. So remember, the coordinates here are 1, 0, and 0, 1, negative 1, 0, and 0, negative 1. Cosine is the x value on the unit circle. So where will the x value equal 0? So let's see. I see the x value is 0 here and here. So that will give me 2 solutions. So I'm going to have x equals pi over 2 and 3 pi over 2. All right, I have 2 solutions so far. Let's move on to the second mini equation. Let's add radical 3 to both sides. That will give us 2 cosine x is equal to radical 3. Dividing both sides by 2, we have cosine x is equal to radical 3 over 2. You should be asking yourself, what is the reference angle? All right, I gave you time to think about it. Hopefully, you were thinking the reference angle is pi over 6. Cosine of what angle is radical 3 over 2? If you have the values on this chart memorized, then you know that the cosine of pi over 6 is radical 3 over 2. So that's why the reference angle is pi over 6. Well, there are 4 angles that have a reference angle of pi over 6. There's one in each quadrant. I can think of pi as 6 pi over 6. I'm using the reference angle. I can think of 2 pi as 12 pi over 6. That makes this 5 pi over 6, and this is 7 pi over 6, and this is 11 pi over 6. Of course, this is simply pi over 6. The cosine of any of these 4 angles is going to be some kind of radical 3 over 2. It's just that cosine is positive over here on the right side of the unit circle and negative over here on the left. In this case, we want cosine of x to equal positive radical 3 over 2. That's why the solutions are pi over 6 and 11 pi over 6. So problem number 11 has 4 solutions.